Hello, everybody. Hi. I hope you are doing well today, and you are enjoying your studies with the ACCA tutor, that is Gerald Mtumkulu. And I hope you will remain loyal to Transcal Consulting Services until you get certified as an ACCA member. Okay, because that's our objective. At the end of the day, you guys have to finish your studies, go to the next level, and then you finish, you are done, you move on with your lives. That's our dream, that's our hope. Okay, so do not feel intimidated or discouraged with the way some of these questions, some of the demands of the other qualification. Okay, this room of mine. It's okay. All right. In this particular video, we are going to explain the nitty-gritties about Example Paurosi, okay, which is a part of the linear programming situation. Okay, and you have read in the slide that the idea behind linear programming, it has nothing to do with computers, but it's something that explains the logical analysis of events. Okay, it gives a logical analysis. All right, and the reason why we included linear programming in the limiting factor analysis is that it helps us to make the computations as fast as possible and in a more accurate manner, where we are involved in a situation where potentially there are two or more constraints. All right, so this is why we need the technique of linear programming. So the Example Paurosi is going to actually help us understand more about this linear programming. So there are certain rules. If you go to your slide here, if you go back a bit, all right, if you go back here, we talked about the steps that have to be followed whenever you want to do a linear programming exercise. The first thing is you have to define the unknowns in terms of symbols. All right, and then you have to formulate equations for the constraints, formulate an equation for the objective, and then graph the constraints and the objective. Lastly, you have to find the optimum solution. Okay, so Example Paurosi reads, Paurosi makes two types of chair, the executive and the standard. The data relating to each is as follows: standard, executive. If we have got materials, that is 2 kg for standard and 4 kg for executive. Labor 5 hours, 6 hours. Contribution $6 per unit, $9 per unit for the executive. There is a maximum of 80 kg 80 kgs. There is a maximum of 80 kgs of materials available each week, and 180 labor hours. This is labor and that one is materials. Okay, demand for standard chairs is unlimited, but maximum weekly demand for executive chairs is $10. Okay, now the question is saying find the optimal production plan and the maximum contribution that will generate this will generate. Okay, now so the first thing we have to do is to do those steps. Okay, so the first step number one, define unknowns. Okay, you have to define the unknowns. Define the unknowns. Okay, so this is where we say let S be the number of chairs, number of standard chairs produced in a week. Number of chairs produced. Okay, per week. Then let E the number of executive chairs produced per week. Per week. Okay, and another important unknown to talk about is C, the contribution. C is the contribution. Okay, once you do this, you go to the next stage. Step 2, define constraints. Define or formulate. Okay. Let's just use formulate constraints. Formulate equations for constraints. Formulate equations for constraints. And in the question, we are given constraints. The first one is materials. Materials. They are limited to what? Okay, materials are limited to 80 kgs per week of material. So materials would be 2 kg for standard, that is 2s, plus 4 kg for executive. Okay, 4 kgs for executive. This one should be less than or equal to 80, because 80 is the maximum available in terms of materials. Okay, 80 is the maximum available in terms of materials. Then we go to labor. Go to, hey, this shoulder of mine. All right, we go to labor. Labor, what are we told about labor? The standard chair requires 5 hours of labor, while the executive requires 6 hours. So 5, 6. 5s plus 6e is less than or equal to 108 hours per week. Then there was something about demand. The demand, they said in terms of the standard chairs, the demand is unlimited. However, for the executive, the standard demand is actually limited to 10 chairs. So per week, we can only sell 10 executive chairs or less. All right. Then we need also to talk about the non-negatives. Non-negatives. We have to formulate the non-negatives. What do we mean when we talk when we say non-negatives? We are saying that since we are producing chairs, there is no way we are going to produce less than 0 chairs. Like we produce -2 chairs, -1 chair, -10 chairs. It can't. It doesn't work like that. So S is greater than or equal to 0. Standard chairs are greater than or equal to 0, or E is greater than or equal to 0. Okay. Lastly, step 3. Formulate the objective function. The objective function, okay, the objective function, it can be easily found from the question itself. Find the optimal production plan and the maximum contribution that this will generate. So our objective function should be to maximize contribution. Maximize contribution. So to do so, C is equal to the contribution per unit. Let's go back to the question. Contribution per unit, we are told for standard $6, for executive $9. So 6s plus 9e. I hope for this first part you are following, and let us continue together in the next video. Thank you.